So in ER diagram, attributes may be drawn in ovals, and each attribute is linked to its entity by a line. So here we can see that lecturer is linked to student, and student is linked to module. The name of the attribute is written in the oval. Now, relationships are an association between two or more entities. Each student takes several modules, and each module is taught by a lecturer. Now, this is a relationship because why we have linked these two and then these two? Because each lecturer is taking multiple students, and each student is taking a module or more than one module. So, relationships are an association between two or more entities, and relationships have a name set of entities that participate in them. So a relationship has a name. So this relationship is given this name, studies. So student studies module. The name of this relationship is studies, which is placed in this diamond box. And the degree, the number of entities that participate, most have degree 2. So there are 2 entities participating in this relation. That's why we have mentioned the degree 2. Last thing is the cardinality, the number of instances of an entity in relation with another entity. So cardinality is the multiplicity. So one student is taking how many modules? More than one, right? You can take more than one modules, right? So you can say many modules. So this round sign over here is representing many. And likewise, a module is taken by how many students? So a module is taken by many students. So that's why we have placed this many sign over here. Similarly, a lecturer is teaching many students, and many students are being taught by a lecturer, right? So this is one-to-many relation. So the cardinality ratios, they consist of 3 kind of relationships: one-to-one, one-to-many, and many-to-many. So each lecturer has a unique office as one-to-many relationship. Every single lecturer is going to be given a unique office. One-to-many, a lecturer may tutor many students, but each student has just one tutor, which is one-to-many. A many-to-many relation is many students are taking many modules. So this diamond box is representing the name of the relationship. Now, one thing that we must remember that many-to-many relationships, if it exists in your ERD, must be broken down into one-to-many or one-to-many relation. How? Uh, Previously we had seen student is linked with module, and both have many-to-many relationship. Many students are enrolled in a module, and a module is taken by many students. Now, this many-to-many relation is broken down into these 3 entities. So a student and the module, and a student enrollment. So student has many enrollments, and many enrollments are in a module. So many to many relationships are difficult to represent. We can split a many to many relationship into 2 one to many relationships. This is how we manage many to many relations in our ERD. To make an ER diagram, you need to identify attributes, entities, relationships amongst them, and the cardinalities. These entities are things or objects. They are often nouns in the description. Likewise, attributes are also nouns, whereas verbs are defined as the relationships between the entities. For example, if you study this example, it consists of university consisting of number of departments. So we're going to just mark the nouns that are existing in this. So courses, students, module, lecturer, departments, these are all nouns. So these nouns are going to be placed in our ERD in such a format, so that we have placed these entities in rectangular box with rounded edges. So now we're going to highlight the verbs or the action words that exist in our requirement. So we have highlighted them, and now we just simply have to and translate those words or verbs into the uh, relationships. So university has several departments is converted into this university, and the department has a connection, and this connection has a name. Then next line is each department offers several courses. So department and the courses consist of this relation. Now we also need to figure out the cardinality. So a university has how many departments? Not one. It can have many departments. And departments have how many courses? Each department has many courses. Right? So we are going to translate each requirement given into this diagram form. Then we have a number of modules make up each course. So modules are part of course. So many modules are part of many courses. This is many to many relationship which needs to be broken down. Then we have student enroll in a particular course. So the course enrolls in many students. When students take modules, so module and student is a many to many relation. Each module is taught by a lecturer. So module and lecturer, so each lecturer has many modules. Each lecturer tutors a group of students. So lecturer and student, exist a one-to-many relation. Each department employs several lecturers. So lecturer and department consist of one-to-many relation. So this is the complete ER diagram. This is where you are going to complete this diagram. So sometimes it is hard to tell if something should be an entity or an attribute. So they both represent objects or facts about the world. They are both often represented by nouns and descriptions. But the general guidelines can help you. How the entities can have attributes, but attributes have no smaller parts. If you just think of an example, for example, a person is an entity. So this entity has different attributes or properties, like it can be broken down into smaller parts, like the person's name, person's address, person's CNIC, person's height, age, etc. So entities can have relationships between them, but an attribute belongs to a single entity. For example, we want to represent information about products in a database. Each product has a description, a price, and a supplier. So suppliers have addresses, phone numbers, and names. Each address is made up of a street address, a city, and a postcode. Now we're going to repeat the same steps. We are going to identify the nouns. So these nouns we have placed here. So these nouns could either be the entity or the attribute. So product, supplier, and addresses all have smaller parts, so we can make them entities. The others have no smaller parts. They are already smaller parts, and they belong to a single entity. So hence they are attributes. Example ER diagram. So now we'll just convert those entities: product, supplier, and addresses. Product, supplier, and addresses. These are the attributes. Rest of the things: description, price. Description and price belongs to product. Supplier has address and phone number and name. Address, phone and name. Right. Whereas address also consists of street address, city, and postcode. Street address, city, and postcode. Each product has a supplier. Each product has a single supplier, but there is nothing to stop a supplier supplying many products. A many-to-one relationship. Each supplier has an address. It does not seem sensible for two different suppliers to have the same address, so there also exists one-to-one relationship. We're going to define this cardinality among the entities. So supplier has many products and supplier has one-to-one address. So some relationships between entities A and B might be redundant. If it is one-to-one relationship between A and B. Every A is related to a B and every B is related to an A. For example, in the example above, the supplier or address relationship is one-to-one, and every supplier has an address, and we do not need addresses that are not related to a supplier. We're going to make those redundant relationship into a single entity. So we're going to just merge those entities. The A and B are going to be put together, and their attributes are going to be the part of the single entity only. For example, in the case scenario above, since supplier had one-to-one relationship with the address entity, so we're going to merge that address into the supplier. So all the attributes of the address will now be merged with the supplier. So the postcode, street address, and city are now merged into the supplier.